Okay, now let us continue with the sodium once again. Sodium atomic number is 11 and atomic number is 20. Atomic mass is equal to 23. That is Z is equal to P is equal to E is equal to 11. Number of neutron is equal to A minus Z is equal to 23 minus 11. Therefore, 23 minus 11 is equal to 12. Therefore, we have a proton is equal to 11, electron is equal to 11, and neutron is equal to 12. So, let us draw the structure. There will be 11 plus charges of the proton and 12 neutrons with no charge. First orbit contains 2 electrons. Second orbit contains 8 electrons. One, 2, 3, 4, 5, 6, 7, 8. That is, we have used 10 electrons now, the maximum. Then we have to take the next orbit and place the last electron in the outermost orbit. Therefore, like hydrogen, it will have to go to the first group. Now we are going to, this is the structure, and you can do, or you can do practices of different elements until you understand it thoroughly. But for simplicity, later we will use another method. Another method is that I will take the example of sodium. The nucleus is 11 protons and 12 neutron. Then we draw in the first orbit. Next we draw the second orbit. Make it 8. And the last one 1. Last one 1. Okay. So actually in chemistry we are interested only in the last outermost orbit. So we can express it in another simple way. How? Just draw a circle and put Na in that. That means this represents the nucleus and the first orbit and the second orbit. That is, nucleus plus all the inner orbits. We are going to draw only the outermost orbit. The same way, potassium. This represents the nucleus as well as all the inner orbits. We are drawing only the outermost. That also is equal to 1. Lithium, nucleus, that this represents nucleus and the inner orbits. Outside 1. Potassium, sodium, potassium. If you need lithium, sodium, potassium. If you need rubidium also, you can write like this. Rubidium, there are many orbits inside. The inner orbits is there, but we only need to take the outermost. So this is the method of keeping different elements in different families, and depending upon the number of electrons in their outermost orbit, they exhibit similar properties, or you can say same properties. Hydrogen is just placed above the first group because it has both the properties of metals and non-metals, but mostly we are studying the metallic properties of hydrogen, and that is why hydrogen is placed separately just above the first group. Then write lithium, sodium, potassium. This much is enough for us up to 10th. Rubidium, the reactions are not there now. Well, let us take the example of magnesium and calcium. Magnesium and calcium. Magnesium, beryllium, you can start from beryllium, the first one. Atomic number is 4, that is, there are 4 protons and 4 electrons. And atomic mass of beryllium is 9. 9. Therefore, number of neutron is equal to A minus Z is equal to 9 minus 4 is equal to 5 neutrons. So, inside there will be 5 neutrons, there will be 4 protons, and then one inner orbit, and after that the outer orbit. We are representing the nucleus and inner orbits by just writing V here. We are only drawing the outermost. The balance will be 2 electrons. Then comes magnesium, whose atomic number is 12, and 12 and atomic mass is equal to 24. 24. So when you draw the beryllium, now magnesium, you make the inside right Mg. This includes the nucleus and the inner orbits, and outside there will be 2. Calcium is also like the nucleus as well as the inner orbits. Outside there are 2. Calcium. Then comes strontium and barium. Just only for the namesake you learn that. Strontium, the nucleus and all the inner orbits. Outside will be 2. And the last is barium, enough. Nucleus and all the inner orbits. So, all these elements have the 2 electrons in their outermost orbit. That is why they are placed in the second group: beryllium, magnesium, calcium, strontium, and barium. Then comes the third group. I am drawing only the third group. Let us take the example of boron, which is having boron. 4 is the atomic number and 11 is the atomic mass. 4 is the boron. No, boron 5. Sorry, 5. 5 and 11 is the atomic number. Alright, okay. So, Z is equal to 5. That much protons and that much electrons. Then neutron is equal to A minus Z, that is equal to 11 minus 5 is equal to 6. So you draw inside nucleus there are plus 5 protons, plus 6 neutrons. First orbit 2, second orbit is you have to fill 5, 1, 2, 3, 4 and 5, finished. Only 5. 5 electrons are there present. So the elements in the third group will have there was a small mistake in that, sorry. 5 is boron and 11 is the atomic mass. So when you draw, it will be plus 5 protons and 6 neutrons. That is correct. Then when you draw, it will be 2 electrons will go to the first orbit and the second orbit does not have 6 or 5, it is only 3. Sorry for the mistake. 3. Aluminium is also like that. Aluminium, this represents the inner orbits and the nucleus. The outside contains 3 electrons. Then after that, one more element is enough for you, like gallium. Gallium also 3 electrons in the outermost orbit. Outermost orbit 1, 2, and 3. Yes, that is why boron, aluminium, gallium, etc. is placed in the third group. They have common properties and common chemical reactions. Many properties are similar or the same, you can say. Then comes the fourth group. Third group finished, fourth group. Only one example I am going to write it is carbon here. Its value is 6 and carbon also has isotopes. But we are taking only one isotope, that is 12 atomic mass, that is P is equal to 6, E is equal to 6. Then neutron is equal to A minus Z, that is 12 minus 6, that is also 6. Neutron is also equal to 6. Plus 6 proton, 6 neutron, first orbit 2, second orbit total is 6. When you finish first orbit 2, the balance is 4 only. Carbon been placed in the fourth group. Then silicon, the nucleus and all the inner orbits outside 4 electrons. Germanium, nucleus and the inner orbits here, the outside will be 4. That is why it is placed in the fourth group. That is fourth. Then fifth group. Now you can guess how many electrons will be in the fifth group. That will be fifth group will be 5 electrons. Let us check the value with the example of nitrogen. Nitrogen atomic mass, atomic number is 7 and atomic mass is 14. Atomic mass is 14. So P is equal to 7, E is equal to 7, Z is equal to 7, A is equal to 14. So neutron is equal to 14 minus 7, that is 7. So 7, 7, 7. Inside plus 7. Neutron is equal to 7, no charge. First orbit 2. First orbit 2. Second orbit. Out of 7, 2 has already taken. Balance is 5. So start drawing 1, 2, 3, 4, 5. Okay. Now we can represent the other elements also in the same way. Same way. Nitrogen, outside it is 1, 2, 3, 4 and 5. Then from the nitrogen, from after nitrogen, which one how much we need in the phosphorus? Up to phosphorus is enough. Phosphorus is also contains 5 electrons in the outermost orbit. 1, 2, 3, 4, 5. So that is why nitrogen, phosphorus, arsenic, antimony and bismuth, they are placed in the fifth group. Now go to the sixth group, the most important element, oxygen. The atomic number is 8 and 60. 8 is the atomic number, and the mass number is equal to 16. So in oxygen, P and that is equal to E. Neutron is equal to 16 minus 8, that is equal to 8 neutron. You can draw oxygen plus 8 P and 8 neutron. First orbit 2 plus 8. 2 is taken, balance is 6. Draw 1, 2, 3, 4, 5, 6. In the same way, after oxygen comes sulfur, selenium, tellurium. Only sulfur is important for us. So we can represent in this way as, which includes the nucleus and the inner orbits. The outermost orbit of sulfur also contains 6 electrons, 4, 5 and 6. So they are placed in the sixth group. They have similar properties. But oxygen is the most important and reactive non-metal. And in almost all our daily life, oxygen has a role. But I am not going, there is no need to explain, you know that. Then the seventh group, very much important. All of them are important in the seventh group. The first one we will see, that is fluorine. Fluorine, the atomic number is 9 and atomic mass is 19. P is equal to 9, that is equal to electron, that is equal to Z. Atomic mass is 19. So neutron is equal to 19 minus 9, that is equal to 10. Let us go. There are plus 9 protons, 10 neutrons. First orbit 2, 9 minus 2, 7 is left out. So draw 1, 2, 3, 4, 5, 6, 7. 7. So I told you, all the others are very important. Next is chlorine. You draw the simplest way, representing the nucleus and the inner orbit area. The outermost contains 1, 2, 3, 4, 5, 6, 7. Chlorine. Then comes bromine, including nucleus and the inner orbits. Outermost contain 2, 3, 4, 5, 6 and 7. Iodine. Outermost orbit contains 1, 2, 3, 4, 5, 6 and 7. So they are placed in the seventh group. The last group is the eighth group, where they are very stable elements. They have a saturated or stable structure of octet, that is either 2 electrons for helium and all the other have outermost 8 electrons. This is called octet. 3, 4, 5, 6, 7 and 8 octet. They are satisfied. They do not want to react with any other elements. That is why they are called noble gases or inert gases, rare gases also. So let us take only the 2 examples. First is helium. Helium, the atomic number will be equal to 2 and helium, atomic mass is 4. Atomic mass is 4. Then they can represent first 2 protons and 2 neutrons. 4 minus 2 is equal to 2 neutrons. First orbit, there is only one first orbit. The 2 electrons are placed in the first orbit. That is the maximum in an orbit. Therefore, that is satisfied. They do not need anything more. Now, next, take the case of neon 10 and 20. I will write it here. Neon 10 is the atomic number and the 20 is the atomic mass. Let us draw the structure of neon. Z is equal to 10, that is equal to P, that is equal to E. A is equal to 20, therefore N is equal to 20 minus 10 is equal to 10. Inside the nucleus, plus 10. Neutron is also equal to 10. So first orbit 2. Out of 10, which is the number of electrons, 2 has been used, therefore balance is 8. So it will go there 1, 2, 3, 4, 5, 6, 7 and 8. That is the maximum in the second orbit. So it is like if you are hungry, usually you eat 3 idlis or 3 chapati for the full stomach. Then after that you do not want any more food at that time. In the same way, they are having a stable structure. Therefore, they do not want to take part in chemical reactions. Okay, now I am winding up. Then we will go to the other next aspects of valency, how to write the formula, and everything will go in the next class. Okay, thank you very much. Thank you very much for joining